Morning, everyone. Hope you have had a nice day so far. Looking forward to spending time with GPT today again. And basically, what we want to do is pick an area of development that I've not done a lot of work in and see how much ChatGPT 4 can help us to be successful building something there. I Let me show my screen. Here we are. Entire screen. Okay, ready to go. Cool. So, if you're watching, please share in the chat where you're watching from. I'm in Germany. Sun is shining outside. After live stream, I'll go onto the balcony and continue working from there. In general, what inspired me to start with this live stream session is this article from Simon Wilson, who said basically there are many things I always wanted to build, right? But when you really start from scratch with something, then you need to read a lot of documentation, figure out things, and it will take 2, 3, 4 days to get these projects done, and it's just way too much for like small projects. And so from that perspective, having an assistant like GPT or GPT-4 actually will help you with lots of the boilerplate, with the basics, with APIs, how to get started, fix some code for you. That's all things that will help you basically get quicker to the point where you basically then can add value and do things as such. So today, what I thought is looking at Streamlit. I've seen a number of my colleagues building Streamlit apps, but I've not done it myself. And so I thought perhaps you can just grab an EVJ database, use the data in there for EDA, and then basically work on Streamlit. Hey, John, welcome from Albania. And doing some EDA, then probably going into scikit-learn, doing some predictions. Perhaps you do them first with Neo4j, and then using scikit-learn to train a model and do something there. So I've not done the scikit-learn part and not done the Streamlit part so far. So let's see how far we get and what comes out of this, right? So I got an empty project here in Visual Studio and on VS Code, and we have our OpenAI ChatGPT here. Good morning. We just do a new chat with 4. So we need to be a little bit careful. Last time we ran out of our 25 messages in 3 hours. So probably I'll gonna ask it a bit more like complex questions as such, so that we don't use up all the messages too quickly. I also heard from some friends and colleagues that those 25 messages fly by like nothing if you have to, refine prompts and things like that. But let's see how it goes. Hey, Mikhail, nice that you're watching from London. I was in London last week and it was beautiful. And I hope the marathon went well. So let's get started. If you have questions, suggestions, just write them in the chat. I'll try to pay attention to the chat as well. And then we get going. Super. So we just asked ChatGPT. We want to code together today. We are going to build a Streamlit app for EDA. Can you give me the files I need to get started with a few. What do we need? We want to have a header, perhaps you start a hello world, right? With a hello world set of visual components. Okay, let's see. Good morning. So we have the requirements txt, of course, with the Python packages and cool Streamlit 08, NumPy, Matplotlib, Seaborn. Okay. I don't know what Seaborn is. You can ask it what Seaborn is, but it's also funny that it says this is a makefile, right? Okay. So we'll just head over to VS Code and create a new file. Requirements.txt and paste them in. So I'm not sure if that's the latest version. So you probably want to go to PyPy and check what is the latest version actually. This is 1.21.0. So let's see if the 1.21.0 pandas is 2.01, I think, right? It'll be fun because I think we'll break some stuff. NumPy. Oh, GPT 1.24.3. 1.24.3. Matplotlib. As you might remember, GPT-4 has a content cutoff date of September 2021, 371, and Seaborn. So we can actually check what Seaborn is, right? So 012.2. Statistic. Oh, I remember Mark used to use Seaborn in some examples. Okay, cool. So that's our requirements, and we can just open a terminal and say pip3 install. Okay, while it's doing this in the background, we go back to our GPT. Okay, what does it do? Oh, this is already quite involved, right? So let's see, it's a lot of stuff. Okay, let's just copy this. And while we copy this, we let it explain what it did, basically. What does the file do? Or explain the code in Python file in, let's say, 6 bullet points, so that doesn't get too verbose. Okay, we'll just create the app.py. So I'll paste this in. And for some reason, pip is taking a really long time. Let's look in Streamlit. 1.21.0 looks okay to me. So we have to have upgrade. In the background. Okay. Super. While it's doing this, let's have a look at what it explains to us. Okay, input required libraries, Streamlit, Pandas, NumPy, Matplotlib, and Seaborn. Main function for the app, file uploader. Inside the main function, a file uploader is created for allowing uploading CSV files. And then sidebar, we create a sidebar for the app, and a really involved app. As the sidebar header and select box for users to choose the type of plot they want to generate. Additional options for each plot type are in the sidebar. Plot generation, depending on the selected plot type. Seaborn is plotting function is called. Bar plot, scatter plot, his plot, and box plot, and display visualizations. 1.24.3, thank you for NumPy. Okay. Let's install the requirements again and see if this works better. Okay, so and then we can try it out. So let's have a look at the code here as well. So this is our title. Actually, what we can ask it as well. What are, let's say, 7 common Streamlit UI elements and their was. I always wanted to know what kind of elements you can do in Streamlit. Text display. I think it can also do Markdown easily, right? There it is, Markdown. Nice. It's funny because it does the inline Markdown thing here. Buttons, checkboxes, radio buttons, which is like checkboxes, of course. And then to create a slider, select boxes. Nice. Cool. And so we have header, title, the file uploader, and when we read the file, it basically just writes data view, data head, sets. So it's more procedural, right? So after the file is loaded, then there is the stuff added to the sidebar, visualization, spot plot, and so on. And then basically x-axis, one of the data columns, and the y-axis from one of the data columns, and then it does subplots for each of those 4 types as such. Nice. So, and now I hope this still works. And if we run this, we didn't get Streamlit installed. So it says we also need to upgrade pip. So 121.0. Oh, we have to use an older version of Pandas because Streamlit is. Actually, it's a good question, right? So we get this error message here, and so let's see if it can actually tell us what to do. I'm just curious. How can I fix it? So I hope, of course, I know how to fix this, but nice. You can just get a pandas version that works. Cool. Didn't know that actually. So let's see. Nice. I learned something. I thought we just put in a fixed pandas version below 2, but of course you can do also semantic version range. Nice. Good thing to be reminded of that. So I'm not sure why the install takes so long. So while it's doing this, is it's kind of interesting, right? So you see that the each data element basically fills in a variable, but in a real UI, these are all async things, right? So you would select something in the select box, and then kind of selected plot is basically set from that. But this looks all more procedural. So can you explain the Streamlit architecture, how it turns the procedural code into the required async code for getting values from UI elements change. Curious if it can explain this. Okay. Report. Okay, there's a bidirectional communication between Streamlit and a browser. I didn't know that. WebSocket, SD cache executor. So, for instance, when we query a database or so, then we could use SD cache basically to not query it again. On change events, re-executes. So just nice. So it re-executes the script and skips the cached part. So interesting. State management. Interesting. So the variables are widget state. Nice. Really interesting. So it looks like a procedural app, but it's actually pretty advanced. Nice. I definitely learned something. I didn't know that about Streamlit. I thought it was much simpler, but it seems to be quite involved architecture. Nice. So, and it didn't like our yeah. So let's see if it still works. It couldn't move the thing, but it wanted to uninstall 124.2 for NumPy should probably still work, right? 2. I can also just use that. All the other things, hopefully. So let's now. I want to see. It still doesn't have Streamlit. That's really weird. Pip3. Really weird. Because pip said that it installed Streamlit up here somewhere. There. And I have no idea why it's so slow. Okay, while we're waiting, what we can do meanwhile is create a Neo4j instance to query. So I wanted to use the recommendations dataset, and we just download the end file with the connection details as such. And the recommendations dataset is basically movie lens and recommendations, movie lens and the MovieDB data. So movies with ratings of users. So we can use this also for EDA and predictions and so on. Okay, let's try this again. I'm not sure why it doesn't like my. Any ideas why it doesn't like my requirements txt? Perhaps you should put in just a fixed version of for pandas. Let's just do this. Pandas 201. Release history 153. Okay. I wouldn't have thought that the requirements bit is the tricky bit. Okay. Cool. So we have our OR instance here now. We can move our home downloads Neo4j Today is the 27th, right? 5/4. And 2.env. And if you look at our end file, then that's basically environment variables for our connection details and so on. And so I think there's like a pythons.env. Use load that. So we can just this as well. And Neo4j. So let me see what the Neo4j driver. 570. 570. And for .env, probably don't use up an ChatGPT message because it's basically just from data inflow .env, and then we can try this out in let's just do and test pi print OS get env, and then Neo4j URI box, right? So we can just load the environment variables from here, and then Neo4j driver. This is an interesting question because the Neo4j driver has gotten a new API in version 4 in recent versions, a simpler API. And so I wonder if you can just tell it about the new API, and you can tell it about the new API, and so this is not so helpful. This is quick example, session execute write, example application. This is way too much code. Interesting. So I thought they had the Python driver. And I think that's also the old API, which is a shame. So I'm not sure where the new API went, but I think my colleagues did a developer blog of the new drivers APIs, the one with the steering wheel. And I just wanted to see if, from Richard, and I wanted to see if it has. So this is the .NET version, and here's the Python version. Okay, so what I wanted to see is if we just paste this into ChatGPT, if it can give us the API call that I need for querying Neo4j. Because that's actually a cool feature about GPT-4, that you can basically, if it doesn't know about an API, you can just copy and paste the docs into it and basically say, give me the API codes that I need. So let's see if it understands our blog post or our text here. So here is a new API description for the Neo4j driver. Can you give me a minimal example to query a database for the number of nodes per label? So we just paste it in, and then Okay, this didn't work. Let's see if it works again. No. Okay. For whatever reason, driver. So. Okay. Doesn't seem to like it. So last time it worked, but this time it didn't work. So we need to basically use our human brains instead. Okay, for change, and do it ourselves. But it should be pretty straightforward. So we just use this example here from the beginning. So that means our Neo4j UI we get from here. We get our username, name, and Neo4j username, and Neo4j password. And then we can UI username password. Okay. And then we just execute this and see if this works. Okay, it seems that worked. And now we can also use a different query that is a little bit more involved from here. So for instance, if I match all nodes and I want to return labels of n, our label and count as count, right? So this should actually work. And then we print our keys and we print our records. Okay. Save it. Unterminated. Oh, I used only 2. So now we got for each label, we have 9,000 movies, 15,000 actors, 3,000 directors, and 6,700 users here. And it basically gives us a driver, and on driver there's this execute query, right? Okay. So now we want to combine this with our Streamlit app. Oh, actually, first we want to get our Streamlit app to run, right? So let's see if it runs now. Streamlit run app. Streamlit. Welcome to Streamlit. I want to leave this. Okay, let's see. Can you see this on the stream as well? Yep. So this is our Streamlit EDA app, and we can browse our CSV file now. So let's see if I have a movies CSV somewhere. Here it is. So we can use the movies file, and now it gives me a data overview and a bar plot. So I had actually missed the data overview in our code. So should we go back and see where in the code it does the data overview? Ah, here, data.head. Nice. So it basically just is able to write the data, pandas data frame head, and turns it into a really nice visualization. Cool. And it also said what is the file here, which is cool. Data overview, and then we have a bar plot here. And this is basically movie ID by movie ID. But what we can do, for instance, we can say countries, how many movies per country are there here, and for instance, we have the budget. Right, so this is a little bit too narrow here. I'll just open it in live coding. So I think we can ask GPT to help us with these labels on the bar plots, right? Cool. So how much time? We have 30 minutes only. That's good. The x-axis labels of the plots are on top of each other, can be render them slanted or vertically. I think it doesn't like us right now. Let me open this as a new chat with history. Something went wrong here. Okay. The labels on the x-axis are rendered on top of each other. Slanted or vertically. Okay, we just get the subplots and then basically we set the tick labels. Okay, so let's try this. So actually we only need to code this one here at this line. It even says at this line, so nice. And we probably do this for the other ones as well. And here too. And box plot. But it doesn't have, of course, x-axis. Okay, and if we go back to our browser, because it said it reruns our app all the time. Let's see if this happens again. Movies. Yeah, it's a bit slanted, but it doesn't help so much, right? So we probably need to do 95 degrees, 90 degrees rotation. Perhaps we want to reduce the tick count. Can we reduce the number of ticks on the x-axis? Scott, welcome. Yeah, this is recorded, so it automatically live streams to YouTube, and so it's automatically recorded in YouTube as well. Okay, there's a max n locator from the matplotlib ticker library. Okay, and we want to import it and then preset a number of bins. Okay. Okay, let's do that as well. So we import a ticker, and then we set the number of bins here. For the bar plot. I think for the scatter plot it's probably the same. Right. And for histogram and yeah, they all look the same, so we can just copy and paste them in here. We probably also want to set the slant for all of them. Nice. So let's go back to our app. This is much nicer, right? It's vertical now, and the distances are good. So similar to the y-axis. Nice. So can we default, because I don't want for testing, open the file and drag and drop this all the time. So it's in downloads movie data. So we can basically ask it, can we default the file upload result to a fixed so I mean, I can try to just say data file equals and then just provide a path, but I don't think that it works this way, to be honest. So we said downloads, movie data, movies. Here. I don't think this will work, but let's see what happens, and then we can have it help us fix it. Oh no, it actually worked. Nice. Cool, it's just a file name. Even better, right? Cool, so it just read the CSV file and then super. So we don't have to do this time and again. Super, and now we want, of course, to replace the CSV with the data read from our Neo4j instance, right? So because it didn't like our attempt to get the data from the API, we just do it manually. So I basically can just say, let's look at the head -1. So that's kind of what we want to get from the database. I hope it's the same results. Actually, we can use our test here to try that. So we just return we call this M, the movie in Cypher, and then we just return as all properties as movie, and then we just run our test again. Oh, of course, we didn't want to have 9,000 movies returned, but just one. Probably a bit too much. Okay, what does it have? Languages. Actually, want to have the keys. So we have languages, IMDb, year, runtime, IMDb rating, movie ID, countries, IMDb votes, title, URL, revenue, plot, poster, released, revenue, runtime. I think most of these are there, right? So what we can actually do is return each of those keys as one line here. So what I just gonna do is I just replace the comma in the selected area with m dot, and for whatever reason VS Code always loses the selection thing. So I'm not sure why. We don't have just one match, we have more than one match here for a comma. Okay. keys here. Choose the selection. $17. That looks okay. Right. So we got all our movies, and hopefully none of these fields fails. So these are all our keys now. Movie ID and so on. And I think movie poster is only poster, and IMDb ID is just IMDb ID. Okay, we fixed this. IMDb ID and URL is probably also URL, and TMBD ID as well. And what was the other thing? Poster. This should be our data from Neo4j. And now I think we have all the things there. Nice. Right. So these are the records that we get from Neo4j for our movies now. Right. And now we have to bring it together with our Streamlit app. Right. So what we're gonna do is we just use the code here. We probably want to use import Neo4j as well. So we can probably not output this anymore and just append this to our file. And what I'm interested in is the caching thing, right? So it said that that it can actually. Let me try something else, because it I think records has also a 2 data frame as well. So what we can try is also print records to the DF and see if this works as well. To think it has. Oh, it's just a list of records. It's not the sum result. Let's see. If I turn this into result and then say this is result, and then perhaps result to data frame. Let's see if this works. 2DF. I think there was a 2DF thing in the API. You can also ask ChatGPT for it. Okay, let's see. But I guess this is so specific that it will make stuff up. So let's see if it makes stuff up. For the Neo4j Python driver, is there a to method turn an eager result into a data frame? Ashwa, you're asking if read CSV of file name creates a bit data frame, and yes, I think it does, right? So as we had here in our app, I basically use the file name and does PD read CSV on the data frame. So that's this data is a data frame as such. And so you're right on that. Okay, let's see what it says. For some reason, there's some issues today, right? So I don't know. I'm not sure how many messages we're using up here. For the Neo4j. Oh, you know what? I don't want to use up all our messages, actually. And I also want to see if it's GPT-4 still. Yeah. So what you want to do is we just go into the Python driver. Where's it? Neo4j Python API, and we just look into API docs, and there was eager result. To eager result. Oh, just use for data frame. And that's data frame 2DF, right? So that's on result 2DF, and I think that's probably not our eager result, but it's another result. And I don't know if the eager result same as a result. And so I don't know if it has actually 2 data frame on it. But what we can probably do is from pandas or import. And then td dot data frame of records. I think this should work as well. Yep. All right, and then we probably want to use instead of numeric indexes, the column names, but I forgot the API call for that, so that's also something that we can ask ChatGPT. What's the syntax to create a df from a list of dicts using the keys as headers? I think you can just pass in headers as like this. No, that's not it. Let's see. All right, but it didn't work for our records here, right? So because our records created an index-based. So I'm not sure if the Neo4j record is actually it's an iterable, closer to a name tuple than an ordered dict. Okay. Can we pass in the column? And then we can probably also check if we can turn them into dicts as well. So data keys to eager result 2DF. So 2DF is only on the regular result, and eager result is has records which are a list of records. So, and does record has an like to dict or something like that? Record, like keys, items, values, data. Here. So we can also just map this into an dot data for RN records. And then we just do this, yeah. Okay, let's see. Okay, this looks better, right? So now our data frame has the right thing. Okay. Oh, we could have just also passed in the column names. Actually, let me try this. I just want to see if this works as well. Data frame of records, comma, columns equals keys. Okay. This looks correct as well. Okay, we could have had it much easier. Good. Should just listen to ChatGPT. Super. So we can basically use this code now in our app.py and to query Neo4j and get the data. So what we want is basically it. So instead of loading the CSV file, we do the following. With Neo4j as driver execute query. This is our query, which you could also make configurable later on. Right? We're only interested in the keys and the records here. So we don't need any of this. And this is our data frame now, right? So, and if records is not none, we just say data is the data frame. So instead of loading the CSV, now we fetch the data from Neo4j, right? And we can probably create a function, read data, and we just say query here. And we return we just return the data frame. And then we say data equals read data query, and this is our query. Super. If you have questions, just bring them along, and then we'll take it from there. And then if data is not none, so we just have this here. Okay. And if I didn't do anything wrong, it should basically, if I reload our app, it missed a positional argument. Query. What did I? Oh. Here. Many values to unpack. Records, keys, driver execute query. Input Neo4j. Perhaps I need to start it. No. So this is an interesting question. Too many values to unpack. Oh, here, I think I removed summary. Here. So that's why it probably. Okay. Nice, right? So we have movie ID and which is a string for me. So what we can do, use like countries and let's say the rating or something like that. Unhashable type list. Countries. Is there also a single country? Poster. Perhaps you can use the year instead. Yeah. Okay, we had 1 year. So I think the problem is that countries and Languages is a list, each of them, and the plotting doesn't like this. So what we can basically do is m.countries of 0 is country and languages is language. Okay. And we can pick country and then rating. Okay, USA has rating 8. Nice. So I was curious about this cached thing. Can you explain how to use st-cached on a database query function? Okay, I think OpenAI doesn't like our live stream. Can you explain how to use st-cached on a database query function? st-cache, okay, it's a decorator which caches result of a function. Okay, because I don't want to wait every time for the database to return. And what we probably want to add is an limit. How many movies do we want to see, right? We have 9,000 movies in the database, but what we can do is actually in our sidebar, where's our sidebar? Here, somewhere. Sidebar, data overview. We can actually say st and select st sidebar dot number input, and we call it number of rows, right? And then we want to pass in rows actually here. So if you do the sidebar there and our rows up front, then we should be able to pass these rows to our read data query. And then we just pass in rows. And instead of limit 1, we do rows, and default is 1. Right? So I hope I understood Streamlit here, and we can use this to, let's see. Okay, this is a numeric input. Can we make this somehow integer input? Step value format. How can I make a take integer? Okay, st-cache. So we have created data from DB, and we just add an st-cache there. Okay, that's the data frame. And okay, that should be and we can say TTL there. Perfect. Right, so that's kind of what we want. So we don't want to requery this all the time. And it takes the inputs into account. So if you change the query and our rows, then it should take this into account. Step parameter to 1. Min value 1, max value 5,000, and step 1. Okay, so we can add st-cache. Let's say we want to cache it for 5 minutes. That's okay. And then we want to have an integer field for our rows, right? So the min value is 1, max value is whatever, 5,000. Current value, we can start with 50, and step is 1, right? Cool. So that means if I reload my Streamlit app here, number of rows 50s. Map keys must be strings, not class int. Where is this? Query rows. Oh, that's my bad. This needs to be a string, of course. SD cache is deprecated. Oh, see? So that's kind of the cutoff thing from ChatGPT. But it seems to otherwise budget. Nice. Germany has higher budgets than US. It's interesting. It's a question if this is the total or if it's the interesting. Okay, SD cache is deprecated, but even so, if I change something here, for instance, if I use now a scatter plot instead, it doesn't reload the database, right? So it's basically just we can, for instance, use budgets in this diagram, and then we basically can see how the budgets distribute here, right? Really nice. So easy. Should have done this much earlier. Okay, read more about SD cache deprecated in the docs. Let's do that. Caching, minimal example, SD cache data and or cache resource. Okay. So I wonder. I think if I paste everything, it might be too much. But I think if you put this in, then perhaps it's good enough. So it says SD cache cache is deprecated. Here are the new docs. How would our example change? Nice. Cool. So it understood I just wanted to see if it understood the docs, right? So not that I've not been able to read the documentation myself, but I just wanted to see if it can extract this information from okay, SD cache data. Easy. So because Streamlit now this differentiates between cache data and cache resource, right? So if I now use budget here, sorry, not budget here, but country here, and let's say rating here, and if I change a different plot, it doesn't reload it. But if I change the number of rows to 500 or something like that, then it actually reruns it, right? So exactly what we wanted. Nice. So this is kind of our EDA bit with Streamlit. So I would say it saved me probably like a day of figuring all the stuff out myself, especially like the Hello World with the selection things as such. So that's quite nice. So in the next hour, what I wanted to do is see if you can do predictions on this kind of data, right? So so I know that with scikit-learn, you can kind of create a model like a random forest or a regression model. and we can do some predictions. So, for instance, what we could do is do something simple like, can we predict the budget from the country or something like that, right? So if you have like the countries, can we predict the budget? So actually, I think, or let's use the year to predict the budget. That could be interesting as well, or the genre. Good question. Perhaps you can use the year and the genre to predict the budget as such, right? So if we go back to our test app, we can basically say this movie is in a certain genre, G, and we just return the let's say the movie title, or we can return movie ID, movie title, budget, and countries of 0 as country, and then probably also the IMDb rating. That's actually not too shabby. We don't need the IMDb ID. But we wanted to have the genre g.name, I think. Right. So if you run this, hopefully didn't mess something up. So it has movie ID, title, budget, country, rating, and genre. If it has more than one genre, we only want to have the first genre. So what we can do actually, instead of fetching it here, we could do a subquery, or we can just turn this into a pattern comprehension as well. And what we would do instead is return movie in genre G of g.name and just return the first entry as genre. So that's a pattern comprehension, like an inline subquery for what you want, right? Okay. And if we do limit 20 or so, then it should give us 20 movies. So we want to predict the budget from genre and year. Oh, we forgot the year. M.year. Comma here. Cool. M.year genre. Sehr good. Okay. Yeah, so we have the year as well. So this is our query for our data. And so let's try to do this first, perhaps in this test file, and then we can take it into the Streamlit app as well. Okay, let's go back to our friend GPT-4 here. So now we want to try a prediction with scikit-learn. How can I predict the movie budget from genre, year, and IMDb rating? What model should I use? How to do test train test split, and evaluate or use the model for some sample predictions. Give me the minimal code with explanation in comments for a standalone Python file. So I don't want it to be in Streamlit right now. Okay, regression model. Cool. So not a random forest, but random forest regressor. Okay. Ensemble model, classification and regression. So it has two models basically. And so what do you have? Pandas, sklearn, pre-processing one-hot encoding. So I think the one-hot encoding is probably for the genre. Let's see. So we read the data. One-hot encoder for genre. Nice. We take our data frame and turn it at the encoded genres as such. And we join it with so we drop the budget from our test data, right? The features and the target. So the target is budget, and we drop budget basically from the features. Nice. Test split set is 20% test, 80% train. Random state is 42. It's a very nice Douglas Adams thing here, right? And then we run a regressor, 100 estimators, fit it to a train data, predict the testing, mean square error, and then we do a sample. That sounds okay to me, right? Any comments from anyone? So Ashwa, you're asking about how we can turn this into a Neo4j graph data. So that's a really good question. We are actually pulling the data from the graph, and then if you write it back, we can either, for the predictions, we can set them as properties, or if you predict relationships, so kind of link prediction, then we can write them back as relationships to the graph. So that's what we can do either in Python or with Neo4j's graph data science library. We can also do this directly in Neo4j as well. But because I haven't done scikit-learn before, I wanted to try this today. So let's see how this goes. Okay, I just copied the code. I hope I understood everything that explained to me. We loaded, train split, random forest regressor initialized, and then predict movie budgets for the tested. Cool. So here's our data, and then we basically do the sklearn pip3 install. Scikit-learn, right? Okay, so we fetch our data from Neo4j. We start with 20, or let's start with 1000. And we just need to adjust this. So this is genre, this is budget, country, as rating. This is as title, and this is as ID. And this is as here. Cool. And then, so we don't need the movie data for us. It's basically this here. Oops. And that's our data. We turn genre into one-hot encoding. So one-hot encoding does basically take an categorical data and turns it into a set of 0 to 1, 0 and 1 columns, where only one of n columns. So if you have n values for genre, you get like n columns, and then one of the columns is 1 for each genre. So it's like an almost like a bit encoding for data. So that because if you train the genre as 0 to n as a single value, then it would actually learn that like the higher the number of a genre is, the better, or something like that. So we want to avoid this. So that's why it's one hot encoded. Okay, so we have our encoded genres, and we drop the original genre here, and we use data of budget, and probably we also want to select what we want to have here. So we want to have actually, it's a good question if I just use drop, because it will do a lot of columns here. So we probably just drop. Does it actually support multiple here? If we drop columns, we want to drop genre, title, country. So we said year, genre should be, right? So we don't want to have title, country, ID. We want to have rating, exactly. So ID. Oops. Keep rating. Genres encoded. And year. Right, that's the three that we wanted to train on. And the budget is basically dropped. So we probably want to also say where m.budget is not null. So we also want to have only movies that have a budget. Otherwise, the training data is probably not so good. Cool. And then test train split. And so it called it IMDb rating. For us, it's just rating. And here is this, right? And then put this again as in one hot encoding, and drop the genre again, and then run this. Okay. Let's see what happens. Any comments from anyone on the code here? Yep. So exactly, Tomasz. That's why I dropped the ID here as well from the columns. Good point. I just wanted to get them in case you want to check out something as well. Okay, let's see what happens. Breaks or not. Should probably have added some outputs. Okay, so we got the data back. One hot encoder, get feature names. Oh, see, so we see that GPT-4 made up probably the one hot encoding. This one. Let's see what it get feature names out. Perhaps that's also a change in the APIs. Is this in, but now the error message is already good enough. But what we can say is, how can we fix this? And we have an error again. I'm not sure what's up today. Something is really weird. How can we fix this? Ah, nice. It even recognizes it. Okay, good. We probably need to change this down here as well. Okay. So model predict. The feature names should match those that were passed during fit. So what did we have? We had rating, year, and genres. What year? Rating. Let's just to check it. I just want to see if he didn't left any weird. Rating, year, country, genre. Budget, rating, year. Oh, interesting. So do we need to keep the genres encoded? So what I think it kind of there's a difference between those and so that's a good question. If our input data has many more genres or prediction test, one hot encoder generates fewer columns and it complains that this. How can we reuse the encoder from the training data? Okay. Also, basically we use the one hot encoder here, and then we also need to transform it over here, I guess, right? Okay. So, oops. Encoder fit. Okay. And then, so here it does fit and transform at once, and I think encoder fit this. And then encoder transform is basically so means for our results here, we would also say encoder transform over here, right? Okay, let's see if this helps. No. So how many do we have? Action, adventure, science fiction, thriller, western. Print sample df dot head. Oh, we have only 2 rows, right? Action, adventure, animation, romance, sci-fi, thriller, western. So this is for action, and the other one is drama. Or perhaps you didn't have a drama. Do we have a drama? There's drama, so that should be drama. What else is different? We have budget rating year rating. I can't imagine that the order is important, right? Or good question. Let's output X. Dot head rating in year. So these are X keys, and so, and then X keys different sample. If anyone has suggestions of what I'm doing wrong, please let me know as well. But we can also ask. So this says there's no difference in the. So I have rating in year, genre, action, animation, documentary, crime, film noir, horror, western, sci-fi. Keys list. Hope it hasn't. Question. You can probably ask it. Is the order of columns important for the what's it called? Unenforced request. I don't think so, but oops. Oh, that's really annoying. Oops. Good to know that it doesn't use the column names, actually. Okay, so that would explain why it's complaining, because it basically year and rating are the other way around. So I hope this is in order dict and can basically work here. Okay. Sample predictions. This is this a data frame again? Oh, and the array. So a year of 2 million for drama and 50 million for an action movie. That sounds sounds about right to me, right? Um, cool. So now we learned how to use scikit-learn with a random forest regressor to take data from Neo4j and predict a property for certain things, right? So if you wanted to, now we could also add things like directors or other things as well for the prediction. But I think genre and year seems to be already a good what is the mean square error? It looks pretty high to me. Or good question. Is this a bit high? Mm. Okay. For EDA, we have our Streamlit lab, right? So we can basically just say take the 10,000, 5,000 rows, and we want to we can do like a scatter plot of one histogram actually, or perhaps I want to do a scatter plot actually of what did we say we wanted to have? We don't have genre here, right? We have year and budget. So we definitely see that the budgets go up every year, and something is off here as well, right? So somehow here are no years rendered anymore. And what does it look like as a bar plot? Okay, so you see that it goes up a lot, right? So that looks okay. So we don't have genre here as such, but so the year should be pretty good predictor. And I always thought that the genre should also be a good predictor. So what we can do in our app, we can actually add the genre from our test here. From our test query, here we are. And see how the genres distribute to budget. So I also want to see how the budget. So actually, I don't know what the bucketing here is for the histogram, to be honest. It's definitely a power law distribution, right? So you have lots of movies with small budgets and few with higher budgets. If you look at the genre to budget distribution here, so it's actually all over the place, right? So perhaps the genre is not such a good predictor for budget, which I'm surprised by, because I thought it was actually pretty high predictor. But it seems that adventure children, crime, IMAX is kind of an outlier. Western musical. So it seems more like the year is a better predictor than this. So if you wanted to integrate the recommendation into the Streamlit app, so this is like almost like one screen, right? So I'm just curious, can I do multiple screens? Can I add multiple screens or tabs to the Streamlit app? Okay. Select box, page 1, page 2, page 3. Ah, nice. So we basically just have 3 functions or 2 functions that do our things. Okay. This looks easy enough. So that means if we have we call it EDA, right? That's our EDA. And in our main, we probably want to have this and number of rows, right? Sorry, the other way around. This is to be in the here, and this is to be here. And the reading should probably also happen in main. And it's a good question how I can pass this from main to very good like this. Yeah. Okay. Then we need our pages and our sidebar. Oops. Copy. What is happening here? Oh, okay. This is our EDA is EDA, and then predict is predict. Pages.keys, and then we do an predict anything, you know. We can basically just set the header to prediction. Okay. Cool. That means if I now reload my Streamlit app, it should say EDA is not defined. Great. So we probably put this over here at the end. Choose a page, visualizations. Okay. Prediction, visualizations. Okay. And it doesn't fetch our data here. Probably just pass it in. This works. Nice. So we can pass in our data from the outside. Right. So budget per country. Cool. And if I now choose this, then it gives me this. Okay, I probably want to do choose a page on top here, so it looks a little bit nicer. Okay, nice. And then now for predict, I think we just import the scikit-learn bits from here. We have a different query, right? So that's kind of a different predict query. It's actually a good question. We could probably even use the same query as before. Let's see. We just add the renames. ID as title, as budget, as countries, as IMDb ID, as heading, as quotes, as language, as plot, as poster, as list, as revenue, as runtime, as TMB, BIB. And we have here and genre as URL as here. Okay. So this gives us the structure, and then in our predict bit, we can basically say we have our data frame here, and then we basically do the prediction. Let's first use the hard-coded bit, and then we can probably do something dynamic. Here, tab. Okay, we need the imports from scikit-learn. And then realize we should have probably actually split it into multiple files, but that's for the next time. So the only thing that we need to do differently is basically we have our one-hot encoder, and here it drops these columns. Actually, what I want to do is basically say data equals data. I just want to keep the columns that I'm interested in, right? So we keep rating here, and that's it. We don't need to drop stuff. And budget, sorry. And then for the train data, we drop the budget, and then we can actually say st.write data.head. So this should show us what is the total data that we use for training. And so, and st.text error and then we want to say st.write sample data frame. We want to see this, and then we want to see these predictions st.write. It could be that we need to construct a string here also, but let's see. Okay, that's EDA, and then predict is what is the key error? Rating year budget. What did I do wrong here? Rating year budget. So you see that my pandas foo is also not so strong. And just ask. Okay. Yes, I'm a human. And so okay. That was just a not very helpful message. Okay, predict. And then we just need to construct a string for st.text. So, or we can probably so. Okay, super. And now we could basically change things by making this more dynamic. So for instance, we could say we want to determine what column we want to predict, right? So we can basically say similar how we select the columns for the visualization. We can basically just say this one here. ST sidebar here. ST sidebar predict column, select value to predict, get out the columns, and can I do default or something like that? Or value equals probably, right? Value equals budget. And then we just use predict column everywhere where we had budget, basically. Here. 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 And I think that's it already, right? Do we have any other query? Okay. Predict. ST sideboard select value to predict data columns. ST sideboard header. How can I insert a default value for? Of course, I could ask the docs, but okay. Okay. So data.columns index budget index. I think that's a usability thing, which would be nice to actually provide the value in Streamlit. Okay, predict. Index has no attribute index. Okay, then we just need to see. How can I get the index of a value out of index type block? Okay, let's see if it works. Yeah, budget. So we predict budget, but we could also predict, let's see, revenue. Okay, so probably what you want to do is not where non k in keys of m, where m dot k is null. So let's skip all the movies that have null values in any of the keys, in any of the values. Oh, actually, that's not useful. Let's use an array here. Rating, budget, runtime, year, revenue. Numeric properties do we have? Votes. Released. Okay. Predict runtime. Yep. So sample predictions for an action is interestingly, an action in 2022 has 2 hours, and a drama from 95 is predicted to have 154. So actually, you should probably output the results for our example and see what. So let's see if I figure out the filter thing for that. It's basically data filter. Input. Input equals input, and then we do here input. Okay, so we have still our input here. Input dot filter. So how do I select rows of a data frame with certain values in? Okay, we're almost at the hour mark, but I think we got a lot of stuff done. So we have a Streamlit app with EDA. We can query from Neo4j. We use .env. We use scikit-learn to predict values, and we integrated it into a multi-page Streamlit app, which is nice. Okay, so that's just an fill expression. Cool. I think we can do this. Input of, we want to say year is equal to 2022. And input of city, not city, but input genre is action. C.write. That's our action selection. And then we have here drama and 1995. I just want to see this. What does it look like? SD dot dramas SD dot header action movies. I really like the turnaround thing with Streamlit, so that looks like a nice thing. And we don't have 2022 dramas, 2022 action movies. Good question. So 95 dramas. What did we predict? Budget. And prediction was 32,000. Yeah, it's not too bad, actually. Right? And then we should probably take another year, perhaps 2018 or something like that. 2018 for the action movies. We don't have 2018 action movies. That's really weird. Action, genre action, year 2018. That's odd. Let's go to our EDA and let's plot year and genre. Adventure, action, IT. Can we do a scatter plot? Does this make sense? No, it doesn't make sense. Box plot is also not helpful. Actually, I wanted to have. Did we have in 2022 action movies? Oh, it ends 2000. So, okay, then I think we need to. I think it could be because the movie lens data set ended so early. Let's use 2000. Okay, predict. Okay, something is wrong here. That's probably also the reason why the prediction is kind of weird. Cool, and with that, I think we covered a lot of ground, and actually a little bit proud of myself what we got done. And I learned a lot in between as well. So this was a really productive 2-hour session, actually, to be honest. Thank you all for watching. I hope you enjoyed it as much as I did. And feel free to do the same. Learn something new with GPT-4. Try and don't be afraid to pick up new software and other things. And this is fun. See you again in either 2 weeks or 3 weeks, depending on my timeline. But thank you all and hope you enjoyed it too. Bye-bye. One.